Hello everyone, you are welcome to this lesson. In this video, you are going to solve this question I have here on the screen. The question says, given F1, F2 and F3, find the force F required to keep the particle O in equilibrium. Okay, so let's look at how we will go about this question. So normally when you have a question like this, you may be required to draw a free body diagram for this system. Okay, so if you are asked to draw the free body diagram for the system, then in this case, for this question, this will be the free body diagram. Okay, so you just have to draw something like this as your free body diagram. Okay, so now let's go back to the question. So let's look at how we are going to solve this question. So you have to determine the force F, which is required to keep the particle O in equilibrium. Okay, so let's look at how you're going to do this. And then you know that in equilibrium, the sum of all the forces acting on a particle must be equal to 0, right? So what that means is that the resultant of all the forces must be equal to 0. Okay, and then for that reason, the components of the resultant must also be equal to 0. Okay, so what you're going to do is that you're going to say the sum of the x component of all these forces, okay, should be equal to the resultant, the x component of the resultant force. Okay, and then that will also be equal to 0. Similarly, the sum of all the y components of all these forces, okay, should be equal to the resultant force. Okay, that's the y component of the resultant force. Then that's also equal to 0. And then the sum of all the forces in the z axis direction, okay, should be equal to the z component of the resultant force, and then that must also be equal to 0 in order for the particle O to be in what? Equilibrium. Okay, so what you're going to do is that you're going to resolve the forces into their various components. Okay, starting from what? F1. Okay, so let's look at what you have here. So with F1, okay, you can see that it has only a y component. Okay, you can see from here, okay, you can see that the F1 lies on the y-axis. Okay, so that means that it has a y component, and then that is the positive y-axis. So we are going to have 400 J. Okay, let's make it 400 Newton in the y-axis direction. Okay, and then let's look at F2 also. Okay, so for F2, okay, it lies on the z-axis direction. Okay, and then it is in the positive z-axis direction. So sorry, that's actually the negative z-axis direction. So you're going to have minus 800 Newton. Okay, okay, that's for the z-axis direction. Okay, and then looking at F3, okay, looking at F3, which is the 700 Newton force, you see that it will have components in both the x, the y, and then the z-axis direction. Okay, because the position vector of this 700 Newton force is going to have components in all the axis directions. Okay, so you have to resolve this force also into its components. Okay, so let's look at how you are going to do this. So to do this, first of all, you must find the position vector of this force. Okay, so let's look at that. So the position vector of this force, okay, let's look at what you are going to have. You're going to have minus 3 in the y-axis direction, and then you have minus 2 in the x-axis direction, and then you have positive 6 in the z-axis direction. Okay, so at the end, you're going to have minus 2i, okay, minus 3j, okay, and then plus 6k. So that will be the position vector for the third force. Okay, so from here you are going to find the magnitude of this vector. Okay, so let's look at what you are going to get. That's going to be the square root of 2 squared plus 3 squared, okay, plus 6 squared. Okay, so let's simplify this and see. If you simplify this, you're going to get 7 meters as our answer. Okay, so to get the force F3 resolved into its component, you're just going to multiply the magnitude of the force, which is the 700 newtons, by the unit vector. Okay, and then we get the unit vector by dividing each of these values, okay, by the magnitude that we just found. Okay, so you are going to have F3 to be equal to the 700 Newton force, okay, multiplying minus 2i minus 3j plus 6k, okay, all divided by the magnitude we just found, which is the 7. Okay, so this is what you have. So if you simplify this, you're going to then have the force F3 in its what component. Okay, so let's look at that. So first of all, we're going to have 700 multiplying minus 2i, okay, divided by 7. Then that'll give us a value of minus 200, okay, I. Okay, so that's for the x component of the force F3. Okay, so let's look at the y component also. For the y component also, we are going to have minus 300j. Okay, and then for the z component, you're going to have plus 600k. Okay, that's what you're going to have. So now we have resolved the third force also into its what component. Okay, so that's what you have now. So let's go ahead and then look at what you're going to do next. Okay, so what you're going to do next is that you are going to apply these three equilibrium equations. Okay, you're going to sum up all the forces in the x-axis direction and then equate it to 0, and then sum of all the forces in the y-axis direction, and then same for the forces in the z-axis direction, and equate them also to what? 0. Okay, but you want to find the value of force F. Okay, but you don't know the component that this force is going to have, whether it is going to have all the it is going to have components in all the axis directions, okay, or it is not going to have components in some of them. So what you're going to do is that you're going to assume that this force F has components in all the directions. Okay, so I'm going to say that F equals Fxi, okay, plus Fyj, okay, plus Fzk. Okay, so I'm going to assume that this force F has the following what components. Okay, alright, so let's look at what you're going to do. So you're going to apply the first equilibrium equation, which says that sum of all the forces in the x-axis direction should be equal to what? 0. Okay, so let's look at that. So sum of all the forces in the x-axis direction should be equal to 0. And then the only forces we have in the x-axis direction will be this minus 200 and then fx. Okay, so you're going to have this to be equal to minus 200, okay, plus fx. Okay, so this means that fx, which is the x component of the force F, will be equal to 200 Newton. Okay, so let's write this here. Fx is equal to 200 newtons. Okay, so let's do same for Fy. Okay, let's solve for Fy also. Okay, so for Fy, okay, that one also you are going to consider the forces in the y-axis direction. Okay, and then for that one also, we know that F1, okay, F1 is in the y-axis direction. Okay, so we are going to bring that here, so 400, okay, and then we have this minus 300 here also, so minus 300, okay, plus Fy. Okay, and then we know all that are going to be equal to 0. So let's solve for Fy. Okay, so you're going to get Fy, okay, to be equal to minus 100 newtons. Okay, so that's it. Fy will be equal to minus 100 newtons. Okay, alright, so now let's solve for Fz also. Okay, let's look at that. So let me just free up some space. Okay, so for Fz, okay, you're going to have sum of all the forces in the z-axis direction to be equal to 0. And then for the forces in the z-axis direction, we have minus 800, okay, and then we have 600 plus Fz, okay, this should be equal to 0. Okay, so from here, we are going to get Fz, okay, to be equal to 200 newtons. Okay, that's what you are going to have. Okay, so now you have been able to find the component of the force F. Okay, so we can write the force F, okay, as 200, okay, I, okay, minus 100 J, okay, plus 200 K. Okay, so that will be the component of what? The force F. Okay, we can find the magnitude of this component to get the magnitude of the force F. Okay, so let's look at that. Okay, so for the magnitude, okay, we're going to have the square root of 200 squared, okay, plus 100 squared, okay, plus 200 squared again. Okay, so let's simplify this and see what you are going to get. So you have the square root of 200 squared plus 100 squared plus 200 squared. Okay, so that gives us the magnitude to be 300 newtons. Okay, so that's how to go about this question.